Hey guys, let's continue. Okay, so what we have here, remember that we have 1635 VSIG we put in here. We want to make this line here. So what we do is actually put the 1635 here to the bottom and meet with GRR of 100. Okay, GRR of 100, we've got the depth. The depth is 5,330. Okay, so that's what we have. So actually, but 650 is only reached for 5,330 instead of 8,000 because that is 8,000. So this 1,650 psi of PVL is only able to lift the 100 BOPD of 35 degree API oil with 100 cubic feet per barrel of GRR, only 5,330, not until the top. So that's why if this one is 8,000, this one is 5,230, mean this one to 2,670 is the fluid level. So 8,000 minus 530 equal to 2,670, which is the fluid level. Okay? Means that if you are in the 8,000 feet here, your pressure is 1650. Okay? A column here is 40. One column here is 200. So this is the scale that I put in this blank mark. And then means 8,000 is 650 to 670 is 14.7 psia. In here is psig, but in here become psia. Okay, so that's it. We have this line of performance of the from reservoir. Okay, so this is a pressure driver should be in a curve, but to simplify I just put it on a line to make it simple. So from here to here is the same from here to here. Okay, it should be like a curve, something like that, but to make it simple just put a line on it. Okay, so now on the next step, okay, on the next step, this is the pressure drivers from the reservoir until fluid level, dynamic fluid level. This is the pressure drivers of 100 barrel oil, 1.995 tubing, 35 degree API, 0.65. So we can use Prosper or pipe seam to create this one. Okay, next one is we try to make in here. Remember that on the previous on the slide, trying to make the gas lift. Okay, so remember that on the problem that we have pressure on the surface, pressure on the PKO is 1,000 psi. Okay, and PSO is 900 psi. So there is a 1,000 PSI different. So PKO basically from here, and PSO is have, so the, if you have a valve it's 100 PSI different. Okay, so those to bottom another PSI. So PKO is in the tubing, PSO is in the what you call it, when when you need to kick off the injection pressure. Okay, so the injection pressure is 900. So this one in a surface. So when you put 1000 psi, 1000 psi means equal to 985 psig. So what I use is a gas pressure at depth of the gas gravity 0.65. This is specific temperature, certain temperature and certain depth. So this is the surface, this is the bottom hole, this is the depth. There are calculations, correlations for this one, but to make simplifies, we use a graphic in this class. But you can use a lot of correlations for many calculations for this one. So if you have 508, this is PSIG, this is PSIG. So if you have 1000 psi here, going 985 psig here, going to the right mixed with 8000 here, going to the bottom, you end up with having this pressure here. The pressure there is, let's see what we have in here. Okay, the pressure is 1560 psig or 1575 psi. The same thing with this 900 psi. So what we have in 900 psi for PSO here become 885 going to the right, 885 going to the right, and goes to the bottom become 1045, or in the PSIA 1060 psi. So this is what we have here. So let us use color red. So what we have is 900 and 1000 here, and what we have in the bottom is 800 feet, 8000 feet, okay, 1175. This one is 60, 75, somewhere around here, and 1060. This is 20 or 40. This is 60. So we make lines. So this is PKO, this is PSO line. Gas injection in here in the surface, if we have 1000 psi with these properties here, it becomes in this area here. So this is what we have. So we continue next week. So if you don't understand it, let me know. So the homework is a picture of this one, and then place it on the assignment that I will give you. Okay, picture of this one. Thank you. Assalamualaikum warahmatullahi wabarakatuh.